ഓൺലൈൻ പോയി എൻ്റെ മിണ്ടരുത് ഓൺലൈൻ പോയി ഉം. ഉം. Good evening. Okay, so very good evening to one and all. I hope all of you are safe, sound, and healthy. Yes, good evening, Mitra. Welcome to my class and welcome to Let's Crack CBSE Science. We'll just wait for one more minute. Just a second. So let us see a few details about Unacademy. Now, these are not things that are unfamiliar to you because Unacademy has grown out to be the India's largest learning platform. Okay, so it is the India's largest e-learning platform. Now, not because of the reason of the pandemic situation, but also for the reason that it offers courses for a school going student to an aspirant who is preparing for a competitive examination. So, this is like a one stop destination for anybody. So, thus, it is the India's largest e learning platform. Now, what you get in an academy? You get access to daily live classes. Now, once you take a subscription to an academy, you get access to the daily live classes wherein you get opportunity to chat with the educator, engage in discussions, ask your doubts and answer via polls. Now, all these facilities while the online class is going on. The courses offered in an academy are well structured in the sense that they are in line with the current examination syllabus. So, this would help you to prepare for the examination better. There are live tests and quizzes. Now, this would help you in evaluating your performance and also gives you an analysis of how well you're getting prepared yourself for the forthcoming examination. Now, as I told you, once you get a subscription, you get unlimited access to all the resources of Unacademy. So you needn't worry if you miss out a live session because there is an option for recorded session wherein you can watch the courses at the comfort of your time as well as your device. Okay. So this is how the comprehensive syllabus would look like. You would have the different subjects, and underneath each subject, you would be having the different courses offered by various educators all over India. So you may go and select the courses as per your requirement and listen to the classes from the various educators all over India. Now, this is the Unacademy Learning app. I repeat, this is the Unacademy Learning app which you need to download from the Play Store and install in your smartphones to get the subscription. So, apart from that, there is a Telegram channel too. Now, the name of the channel is Quest 12 CBSE Commerce. So, what you need to do is download the Telegram app in your smartphones and type the link as shown in the URL in the space in the space of the URL as shown in the figure, and then click to join, wherein you get access to the resources posted by the Unacademy as well as educators. Now here is a detailed description on the class 12 subscription fee details. Now there are various plans available ranging from a month subscription to a year subscription. Across each of the plan, the cost of the plan is also listed. Okay, from 2,500 to 12,500 if you're opting for a month or a year subscription. But if you take my referral code or my promo code SLYT, you get a reduction of 10% or a discount of 10% on the fee and on various labs. So if you are a class 11th or 12th student, I would definitely recommend you to take a year subscription. So that is not only for your forthcoming board examination, but also for the competitive examination like joint entrance examination that you would be looking forward to. So please do not get late. Take a subscription as soon as possible, and if you want, you can use my promo code to get the discount. Now when you get a subscription, it is not just a particular educator's class that you would be seeing. You get access to all the classes posted by all the educators. Okay. Now, as I told you, we have been dealing with CBSE Class 12 Computer Science. Now, we were going as per the NCERT syllabus. So, we started with the classes on Python. We had introduction and then we learned around till functions. Then we took up the topic of data structures. Now, as per the syllabus, you need to learn two data structures, namely stack and queue. Okay. So, for the last couple of classes, we have been dealing with stacks, and we had an introduction to stack. Then we had learned about the different operations. In the last class, we started with the stack application, and today we'll be seeing the part 2 of stack application. So, we just discussed two of the applications in the previous class, wherein the rest of the applications we would be dealing in today's session. Okay, so in short, we'll be having a small recap of what we have already seen in the last couple of classes with regards to data structures and stacks, and then the stack applications that we are left with. Okay, so I hope all of you are ready, and so let's start. Yes, Kuldeep, good evening and welcome to my class. So let's have a small recap of what we had seen in the previous classes. Now we started with the definition of stack. Okay. Now what is a stack? You had different classifications or different types of data structures. From that we saw that stacks comes under the compound data structure. Now the compound data structure was again divided into linear as well as non-linear, right? So when we talked about linear, we told that for a linear data type, the values comes in a sequence, right? Along a line. Now, if you're talking about the stack, this data structure can grow in size as you add new elements and shrink in size as you delete each element. Okay. So the growth already always happened in a linear fashion. So a linear structure implemented in LIFO manner. Now what is LIFO? Last in, first out technique. Okay. So in LIFO manner, where the insertions and deletions are restricted to only one end, which is called as the top of the stack. Now you can add elements as well as remove elements from the stack, but the technique used in stack is LIFO or last in, first out. Okay. Now the stack is a list of data that follows the rules. Now this is the same thing that we are going to list again. Now when you're talking about inserting an element or adding an element to the stack, we call that particular operation to be push, and with regards to removal of an data from the stack, or deleting an element is called as the pop operation. Yes, Pushpendra, good evening and welcome to my class. Welcome to Unacademy. Yes, I'm fine. We have been dealing with CBSE Class 12th Computer Science, and today we'll be looking into the applications of stack. We actually had one previous class wherein we started with the application of stack, and we'll be looking into the evaluation of postfix expression today. Okay. So I hope all of you are also safe and sound. Okay. So the different applications of the data structure stack. Okay, so what are the different applications for which this particular data structure can be used? Now, as per the definition, we are clear that we can add an element to a stack, we can delete an existing element from a stack, right? Now, but all the additions or deletions can happen only through one end, right? Now, and we had different terms associated with the operations. Say for insertion, we use the term push, and for deletion operation, we use the term pop, right? Now, here we are going to see the different applications for the data structure stack. Now, I have just listed 5 of them, wherein you can have more applications also using the same data structure. Now, the applications are reversing a line, conversion of infix expression to postfix expression, evaluation of the postfix expression, then it is used in a concept called as recursion, and then for a method called as backtracking. Okay. So we have just come across these applications, among which the reversing a line and the conversion from infix to postfix was already covered in the previous class, where we'll be having a short recap of what we covered in the last class. Now, what do you mean by reversing a line? A line is nothing but a line of text, right? So that means it is of data type string. Now, suppose I'm writing, I'm writing a string teacher. Now, all these are characters. Now, if I'm reversing it, in what order will this be printed? So this is the order in which it would be printed, right? Now, if you're inputting such a string, how can you arrive at a reversed string on the screen? So the most simplest example of stack is definitely reversal of a given line. So this, how this is accomplished is, what you need to do is you need to scan this string from left to right. Now, as you're reading the characters, what happens? You come across character by character, right? Now, when you come across each character, the character is pushed onto the stack, right? So imagine that this is your stack, and you would have P, E, A, C, H, E, and R. Now, what is top pointing to? Top is pointing to the lastmost. Reversing a line? Repeat line? I didn't get you. See, so what happens? Now, what is the variable top pointing to? Top is pointing to the last element that was inserted in the stack, right? So it is pointing to R. Now, when you are attempting the pop operation or removal, what happens? The removal happens character by character, right? So when the line is finished, we pop the characters from the stack, and when you try to print it on the screen, it comes in the reverse order. So this is how a reversing of the line of text happens using a stack. Now we have just a very small example to understand this. Okay. Now we have a string of the name Python, which is saved onto the variable str. Okay. So the characters are Python. Now what happens? This is position number 0, and then you have 1, 2, 3, 4, 5. Okay, since it is having 6 characters, the last position number is 5, right? Since the index value started from 0. Now what would happen? As you read each character, as you're traversing through the string, traversing means you're visiting each character by character in the string, right? So what would happen? Each of the characters that you come across would be pushed onto the stack. Okay, so what will happen? So P will be the character that would be in the last position of your stack, right? Because the insertions and deletions happen only via this end, right? Which is called as the top of the stack. Now when you had only one character, that particular character would be pointed by the variable top, right? Yes, Google, good evening and welcome to my class. And then as you come across each character, it would be pushed onto the stack, and what would happen? The character would fall one on top of each other. Now as you reach the end of your string, what would happen? Now n is also pushed onto the stack, and now your top would be pointing to the character n, right? Okay, so these are the steps in which you push each of the character by character of the string onto the stack. Now, what is the next step to be done? You need to do the deletion operation, or you need to pop. Okay, so initially this is your condition, step 1, wherein the variable top is pointing to where the character n, right? Now from here, when you are initiating pop, what happens? Each character by character would be popped out, and then as you print the character, this is how it would be appearing on screen. Okay, and hence the string gets reversed. Okay, now how did this happen? This could be accomplished because the stack followed a LIFO technique. That means last in, first out technique, where the characters would come in the reversed order, and hence we say that our string is reversed. Okay, so this was the first application using stack, and the second application wherein we discussed and covered in the last class was conversion of infix expression to postfix expression, right? Now the complex arithmetic expressions can be converted to polished strings. Now polished strings means it includes both prefix as well as postfix notations. Okay, now this can be executed in two operands and an operator form. The polished strings refers to a notation which all notation prefix as well as postfix. Now what is prefix? Here you're fixing the position of the operator, right? When the operator falls in between the operands, we call it as infix. When the operator is fixed before the operands, it is called as prefix. Okay, when you fix the operator after the operands, it is called as postfix. Okay, so and we saw that while conversion, the certain things have to be taken care. The first thing is called as the precedence, and the second thing was the associativity. So these are all the topics that we covered in our last class. Okay. Kuldeep, this is because you couldn't attend my previous session. In the previous session, we already discussed about reversing a line as well as conversion from an infix to postfix, wherein in today's class, we'll be learning how to evaluate a postfix expression. That will be coming very soon after just 1 or 2 slides. Okay. These slides I have included just to brush up what we have already covered in our last class. Okay. So when you're trying to convert an infix expression to a postfix, see, infix meaning an expression of the type A plus B, wherein A and B are operands. What are they? Operands of value, right? So operands, operator, operand, right? When you have a system like this notation is called as infix, wherein you are fixing the operator between the operands. Okay, so what is this notation? Infix. Now what is prefix? Prefix is a notation in which you are fixing the operator first or before both the operands. Okay, so this is how a prefix notation would look like. So for the same infix expression, how would the prefix look like? You would have the operator followed by the operands plus AB. Okay, now if you're going for a postfix notation for the same expression, which is the expression A plus B, right? So the postfix notation would be, you would have the operand followed by the operator. Is the idea clear? So you would have the fixation of the operator after your operand. So how would this look like? A, B and then plus. Yes. Gokul, hello and good evening to my class. Welcome. So this is how the postfix notation would look like. Okay. So while evaluating an infix expression, there is an evaluation order. Evaluation order means the priority that has to be taken care of. Now this is what we had listed using brackets or parentheses, which would give you the evaluation order. And then the first priority has to be given to exponentiation. After that, multiplication or division, followed by addition or subtraction. Okay. Yes, Amritesh, good evening. Welcome to Let's Crack CBSE Science. So while evaluating an expression, what kind of expression? Infix expression, right? So this particular evaluation order has to be taken care of, wherein you give the first priority for the brackets or parentheses, followed by exponentiation, then multiplication or division, and the fourth priority for addition or subtraction. So this is what we had mentioned by precedence. Okay, precedence meaning the priority to be given for each of the operators. Okay, now so we had seen all this also in the previous class, and this was a table to help you understand the different notations, like what is an infix notation, prefix and postfix. See here, this is the same thing that we learned in the previous example. Okay. So I hope Kuldeep you could understand the notations. Okay. Hindi, I'm so sorry. I'm from the south and I'm not that fluent in Hindi. My Hindi is too bad, beta. So you'll have to bear with me in English. Safdar, I hope you heard me. I'm from the south and I do not know Hindi. It's very difficult for me to speak in Hindi. Okay. So So the first thing that we're going to see now is the advantage of postfix expression over the infix expression. Okay, so till the last class we saw how an infix expression can be converted to the postfix equivalent. Okay, now we need to understand why are we doing it, or what is the advantage of a postfix expression when compared to an infix expression. Okay. So I hope you can follow. So you can ping me or you can post in the chat whenever you find a difficulty in understanding. Okay. I just know certain words in Hindi, but not very fluently. I cannot explain the whole concept in Hindi. Okay. So the first thing that we're going to see is why we go for a postfix expression when compared to infix expression. Okay. Now, an infix expression of the type A plus B. Now, this is something that is easily understandable by the human beings, but not when you consider a machine. Is the idea clear? It is it is an understandable form for humans, but not for a machine. When you consider a machine, this expressions that can be easily understood by the machine. That means मशीन को जो एक्सप्रेशन समझ में आता है वो ईदर प्रीफिक्स होता है या फिर पोस्टफिक्स होता है. इज आइडिया क्लियर? इनफिक्स तो हमें इजी लगता है, बट मशीन को क्या इजी लगता है? ईदर प्रीफिक्स और पोस्टफिक्स एक्सप्रेशन. बट व्हाई? बिकॉज See, when you're writing a prefix or postfix, we saw yesterday what. Yes, we'll be completing the syllabus, but in due course of time, Safdar, we are just in the data structures right now. So, and in Stack app, we started with the stacks, and actually, this is our fourth class with regards to the stack as per the syllabus. Okay, so the expression will not be containing in any parenthesis, right? So we already saw in the previous class when we were dealing with postfix expression, what is it? The postfix expression doesn't have parenthesis, right? Now, using stacks, the postfix notation is easier to be evaluated by machines, okay? So how does the postfix expression gets evaluated by a machine? With the help of the data structure stack. The second point. And the third point, now when you're writing a postfix or when you're writing a prefix notation, you needn't consider the operator precedence. What is operator precedence? The priority of the operator. Nor do you have to consider or bother about associativity, right? Associativity means whether you're evaluating from left to right or whether you're evaluating from right to left. Okay. Now this makes it easier to evaluate. So the postfix notation has neither the operator precedence nor the associativity. Now, which makes it easier to evaluate. Okay. हमसे क्या syllabus? I didn't get you, Kuldeep. You were asking CBSE का syllabus का? I didn't get that word. हो क्या? Did you mean कब खत्म होगा? Okay, so the postfix expression doesn't have an operator precedence nor the associativity. And also the postfix notation itself reflects the order in which the operations are performed. Now, since it is not having any parenthesis, since it is not taking into consideration any operator precedence, what we need to understand is the notation itself would help you in understanding which is the operation to be performed in which sequence. Okay, that means the order of evaluating or performing the operations are actually hidden in the notation itself. So this makes the machine easier for it to be converting or for it to work on. For this reason, the machine's ops, which either postfix notation or prefix notation, here we'll be totally focusing on the postfix notation. Okay. Okay, thank you. So evaluation of a postfix expression using stack. So this is the main thing that we're going to learn. What are we going to learn? We're going to learn how to evaluate a postfix expression using stack. Okay. Now, we understood that we are given with a postfix expression, and to evaluate or to find an answer to this, we need to use the data structure stack. Okay. Now, this is the understanding of the question, but there is an evaluation rule which has to be followed. Okay. The first thing that we need to understand is whenever we are given with an expression, okay, what is the expression we are given with? We are given with postfix expression, right? How do you scan the expression? You scan the expression from left to right, isn't it? You scan the expression from left to right. Now, as you scan an expression, you get character by character or element by element. Okay. Now, this element can be either an operand value or it can be an operator symbol. Can it be anything, any other thing? No, right? Because parenthesis is not, you do not have a question of parenthesis inside your postfix expression. उसके अंदर क्या क्या होगा? Either operand होगा या फिर operator मिलेगा, right? So when you're reading a postfix expression and what is the direction? Direction कैसा है? From left to right. Okay. So each time you come across a character, So this can be either an operand or an operator. Now the next thing that we need to understand is what is the action to be taken if the element red is an operand or if the element red is an operator. Okay. Yes, Riyansh, good evening and welcome to Let's Crack CBSE Science and welcome to my class. So push the element in the stack if an operand is encountered. So when you are reading the element and if you find that the element is an operand or if it is a value, what is the action to be taken? You need to perform the push action onto the stack. That means adding an element to the stack. Now what is the action to be taken if it is an operator? Now in this case, we need to have two subparts. Now this operator can be either a binary operator or a unary operator, right? Okay, so the operator can be either binary or unary operator, right? Now what is the meaning of binary operator? Bi meaning two, right? So suppose you are writing an expression a plus b and see here plus is your operator. Now the plus takes two values for the operation to be performed, right? So two operand values to be taken for the operation to be performed. If any operator that takes two values is considered to be a binary operator, okay? And if it takes only a single value or a single operand for performing, say for example, the logical operator not, okay? So not would only consider a single operand in the sense this relational expression would be treated as a single operand, right? Now in this case, you are prefixing the operator with the expression and this whole expression would be treated as an operand. Okay. So not of A less than B. Now what happens? Here you have only a single operand, right? And hence not is a unary operator. Is the idea clear? So if the element is a binary operator, what is the action to be taken? Pop two operands from the stack and then evaluate it. Now why do you pop two operands or why two pop operations are initiated? Since it's a binary operator, you need two values to work on it. But if the element is a unary operator, what happens? You just need to pop one operand. सिर्फ एक ही operand आपको pop करना पड़ेगा. कहाँ से? Stack से. Okay, and then you have to evaluate it. Now once you evaluate it, what you need to do is the evaluated result is not actually your result for the entire expression, right? Just the intermediate expression. So whatever result that you get, you need to again insert it into the stack or push it onto the stack. Now this procedure will have to be repeated till you end, till you reach the end of the expression. Which expression? Till you reach the end of the postfix expression. Okay, so this is the rule. Now we're going to write it as an algorithm. Okay, now this algorithm is nothing but the same rules but put it in an format so that this can be easily understood. Okay, so what is the first thing to be done? The first thing is you need to read the expression from left to right. Now after this algorithm, we'll be looking into certain examples. So this would help us to understand or learn the conversion or the evaluation better. Okay, so what is the first thing? You need to read the expression from left to right. So this is a first concept that to be understood. Now when you're doing this process, what happens each time you come across an element, right? So if this element is an operand, what is to be done? You need to push the element to the stack. So what is the action triggered? Action triggered is pushing. कब करेंगे? जब आपको पता चलेगा कि आपका एलिमेंट एक ऑपरेंड है. Okay, So if you're encountering a value, you need to push it or add it to the stack. Okay. If the element is an operator, now what is the next thing? If the element is an operator, now we already saw that और push आपको CS में क्या आता है? पता नहीं. I don't know. If the element is an operator, what is to be done? You need to pop two operands. In which case, in the case of if the operator is binary, and you need to pop just one operand, in which case, in the case of a unary operator, we already saw that in the case of the rules. Okay. Now, once you have popped out the values, you have the values as well as you have the operator. What you need to do? You need to perform. मैम ये हिंदी का स्टूडेंट है कौन रियांश Okay, fine. That's nice. I'm happy that you're a topper of CS and you understand both Hindi as well as English also. Okay. So I think I'm relieved from the task of trying to attempt talking in Hindi, right? Okay, so I'll start explaining in English so that I'll be more convenient. Each time I try speaking in Hindi, it becomes very difficult for me, hunting for words. So now I told you if an element that you encounter is an operator, you need to have two decisions to be made. What if the operator is a binary operator or what if the operator is a unary operator? Now what happens? In the case of the binary operator, two values are taken from the stack or popped from the stack. But in case of unary operator, just one value or an operand is popped from the stack. Now what you have right now, you would have the values associated with the particular operator, right? Now, next step is evaluation. Now, why evaluation? With the values, right? The values and the operator, you can evaluate the expression formed by the operator and the operand values. So, you get a result. Fine. So, push the result of the expression in the stack. So, whatever result that you get, you need to push it into the stack. Now, this particular step, I mean 1 to 3 would be performed repetitively till you find that there are no more elements in your expression. That means when your postfix expressions, the entire elements have been, you are done with your postfix expression. That means you have reached the end of the evaluation. If not, what is to be done? You need to go to step 1 and then reiterate through the processes step 1, 2 and 3. Okay. Only then the evaluation can be done. Okay. So I hope the algorithm is clear to you. It will be more clear to you when we come across the example in the next slide. Okay. So, chalo bachcho, let's see the example. You're given with a postfix expression and see this. This is your postfix expression. Okay. You have A, B plus C asterisk D slash. Okay. Here A, B, C and D are your operand values. Okay. And the operators are plus, asterisk and slash. Okay. Yeah, happy Diwali in advance to you too. Probably we'll be having a class on Diwali also, I think, in YouTube. So you're given with the values for the operand A, for B and C and D. Okay. So you see here, this is your expression and just a second. Having this problem with my pen tablet. Okay. So this is your postfix expression. You have been given with the values of your operands. What are the values? The values for the operand A, the value for the operand B, C and D. And what is the task that you have to do? You need to evaluate or find the value of the expression. Now, what is the expression? The expression is a postfix expression. Okay. Now, what is to be done? You have to scan the expression from left to right. Isn't it? So, this is the direction in which you're going to scan. This is left to right. Okay. So, which is the first element that you would be encountering? The very first element, it is A. Now, what is A? A is an operand. Now, what is the action to be taken when you encounter an operand? It has to be pushed onto the stack, right? It has to be inserted to the stack. So, look here, I have demonstrated that. Now, A is in the bottommost element and see this arrow indicates the indication of top. Okay. Now the top of stack is pointing to the only element in the stack, and which is the only element? The only element is A. Now what happens? After that you read the next element, which is the next element B, right? Again an operand. Once you encounter an operand, what is the action to be taken? Pushing to the stack, right? So hence this is how it would look like, and now top is pointing to the operand value B, right? Okay. Now the third element is an operator or plus. Okay. So what would happen when you encounter plus? Plus is a binary operator, right? So since it's a binary operator, how many operand values have to be popped from the stack? You need to pop two operand values from the stack, right? So the two values that will be popped from stack are A and B. Now what you need to do, you have the operand as well as the operator, right? So what will happen? The value of the A was given to be 2 and B as 3. Now substitute those values, what would you end up in? 5. Now this is an intermediate result, not your final result. So this intermediate result would be pushed onto the stack, and see here 5 would be pushed onto the stack, and now top is pointing to 5. Is the idea clear? The third element was an operator plus. So we popped two operands from the stack. Why? Because plus was a binary operator, and the two operands popped from the stack are A and B, and now you evaluated A and B to get the result 5. Okay. Now which was again pushed onto the stack. Now again when you scan through the expression, so which is the next thing that you encounter? C, right? So C is an operand, so what is to be done? It would be pushed onto the stack. Okay, again when you read through the expression you get asterisk. Okay, now what happens with asterisk? When you encounter an operator you need to do the popping operation to be performed. Now I know that asterisk is a binary operator. So how many operand values has to be popped from the stack? Two values, right? So C and 5 would be popped out. And then you have a value for C which is 4, right? So what happens? 4 into 5 would be calculated. The result is 20. Again, this is pushed onto the stack. Fine. So what would happen? So you had reached till here. Okay. Now which is the next element? Next element is D, which is an operand. So what would happen upon encountering an operand? What is the action to be performed? The action to be performed is pushing to the stack, right? So what would happen? Again, D would be pushed onto the stack, and now what is top pointing to? The topmost element is D, right? So we have 20, and upon 20 you have D. Now which is the next element? Next element is the operator. Now what is the operator? Slash operator, right? So it has to perform the division. So when you pop the operands, now how is the division going to be performed? 20 divided by D, right? So what is the value of D? We had already seen in the question. The value of D is 5, right? So 20 divided by 5 and the result would be 4. Okay. Now whenever you're getting your result, what is the action to be taken? You push the result onto the stack, right? So now the stack is left with the final answer. The final answer of your postfix expression, right? Now we have reached the end of the expression also. Now what is to be done? Just pop the result from the stack. And what is the final result? The final result is 4. And what was your expression? The expression was AB plus C star D slash, wherein the value for A, B, C and D were given here. Okay. So I hope you have understood this. Anybody who is having doubt may please ask me. I'm ready to explain it once more. But this is quite easy if you would ask me. Evaluating a postfix expression is very easy when you compare it to, converting an infix to a postfix expression. That was a pretty long algorithm. We had little confusing steps, okay. In the case when you had to push the operator onto the stack, there had to be decisions taken with regards to precedence, right? So when you consider that, evaluation of the postfix expression is very, very easy. Now this can be done with the help of a stack. Now what are the rules to be considered here? When you see an operand, it is blindly pushed onto the stack. When you encounter an operator, now the operator is interpreted to see whether this is a binary or a unary operator. Now if it is a binary operator, how many values have to be popped from your stack? 2, right? And then you have the 2 values and then the operator perform the operation, you get an intermediate result, push it onto the stack. Then go on with your postfix expression, repeat the steps, okay. Now if the operator is by unary, you just need to take a single operand from the stack or pop a single operand from the stack and then do the evaluation and then again push the result onto the stack. Now remember, whenever you're pushing the result onto the stack, the results are intermediate results and not your final result, okay. Now this was a case in which we evaluated the expression and the expression was a arithmetic expression, okay. The expression was arithmetic postfix expression. Now let us see how to evaluate a postfix logical expression. Okay, now what is it? It is not an arithmetic expression. Here we are going to see a logical expression. So you have the logical operators not, or, and, etc. Okay, and the operand values here would be either true or false, right? Only Boolean values would be there. So the values are either true or false. Now we are given with an if postfix expression. Here I'm not going to draw the stack. Instead I'll be listing what is the contents of the stack. Okay. The question says evaluate the postfix expression showing the status of the stack in tabular form. Okay. So what you need to do is in each step you will be taking an input element and then you would be suggesting which is the operation to be done. Okay. The operation could be either push or pop operation, because when you're encountering a value, what is to be done? When you're encountering a operator, what is to be done? Now these are the only things to be done here. Okay. So first step, you get the first input element. What is the first input element? The first input element is true, right? Now what is true? True is an operand or a value. Now what is the action to be taken? It is to be pushed. So what will be the content of the stack? True. Okay. Now as you move from left to right, which is this next operand value, it is false. Upon encountering false, again push, and what would be the contents of the stack? True, comma, false, right? Now false is at the top of the stack. Okay. So the values that would be coming in the right, you have to assume that the it is pointing, or this value is getting pointed by the top of the stack. Okay. And then the next value is again true. So this is an operand. Upon encountering an operand, what is to be done? You have to push the value onto the stack. And what will be your stack content? It will be true, false, true. Okay. Now, which is the next element? The next element is an operator. Now, what is the operator? The operator says not. Okay. So when you encounter an operator, what is the first thing? You know that it is popping action that has to be taken. So you need to understand whether it is a unary operator or a binary operator. Now, in what category does not falls in? Not as a unary operator, right? So how many values have to be popped? You just need to pop one operand value, and that would be the one that is pointed by top, right? So what is the value? The value is true. So not true. What will be the result of this expression? Not true. You have to negate the value, right? So true is your value. You are negating by prefixing not with true. So what would be the result? The result would be false. So when you get false is again an operand value, right? So whenever you get a value, it has to be pushed onto the stack, and see how the stack contents would be. At the bottom of the stack, you would have true, upon which you would have false, and on top of it, you have false, which you have calculated right now. So this is your intermediate result, and this result would be pointing at the top of the stack. Okay. Now what happens? You have the action performed upon receiving the not operator. Now which is the value that is to be considered next? False. This is your next element, right? Upon encountering false, this is an operand. What is the action to be taken? Just push it onto the stack. So this would be the content of your stack. There's a problem with my pen. So this is the content of your stack. How does it look like? It looks like true, false, false, false. Okay. Now, which is a value that is pointed by top? Top is false, right? Now, we come back to our expression. Now, what does the expression say? You have or. Now, or is an operator. Operator, upon encountering an operator, the action to be taken is pop, but how many operands to be popped depends on the type of your operator, right? Now, OR is a logical operator. Now, it is a binary operator. So, how many values have to be popped? You have to pop two operands or two values. Now, the one first popped out would be false. The second value popped again false. Now, you would do false or false. What is the result? Again, false, right? When two values are false and you're trying to do logical OR, the result is also false. Now this result is again an operand value. What is to be performed with the operand value? It has to be pushed onto the stack, right? So see, now your stack contents are true, false, false. Okay, true, false and false. Now this false is a value pointed by top. Okay. Now you're done with OR operator. Again, scanning your postfix expression, you get AND operator. Now when you come with AND operator, what is the action to be taken? Operator. So you need to pop, right? How many values would be popped from your stack? Two values, right? Now which would be the value? First popped value would be false. Now your top would point here. Again, this value also has to be popped and the value is false. So you get false and false. What is the result? The result is again false, and this is again an operand value. Now what is the action to be taken? It has to be pushed onto the stack, right? So what will happen? You just had true in your stack, and upon which on top of true you now have false. Okay, because false is your intermediate result. Okay. Now coming back to your postfix expression, you have the operator OR. Okay, what is it? You have the operator OR. Now upon encountering the operator, you find that this is a binary operator. So to evaluate the binary operator, you need to pop two values from the stack. What are the values? True and false, right? So how would you write? True or false? What is the result? If any one of the value is true when you are trying to evaluate with the operator or, your result is also true, right? So this is your result. Now whatever be the result, you need to push to the stack, right? And then this is the intermediate result again. Now we find that we have come to the end of the postfix expression. Do you have any other element in the postfix expression? No, right? So this means we have finished the postfix expression, or the result right now in the stack is your final result. Okay, and what is the result? The result is true. Is the idea clear? So this is how you evaluate a postfix expression. We have seen two examples here. One using arithmetic expression as well as another using the logical expression. Now, there are only simple things we have to consider when you're considering the evaluation of a postfix expression. You need to read the expression from left to right. This is the first thing to be kept in mind. Okay. Now, as you read the expression or as you encounter each element by element, the element can be either an operand or an operator. When you encounter an operand, it has to be pushed onto the stack. When you encounter an operator, you need to interpret, you need to decipher the meaning, like whether the operator is a binary operator or a unary operator. Fine. When it is a binary operator, by meaning 2. So how many values you have to pop from the stack? 2 values, right? Now you pop the values, you have the operator, perform the evaluation, do the evaluation, you get a result, right? Now the result is an intermediate result. Again, it has to be pushed onto the stack. Okay. Now what happens is, if it is a unary operator, unary meaning just one. So how many values have to be popped from your stack? Just one value. Okay. So what happens? You pop the value with the operator, you perform the evaluation. Whatever result you get, you push it onto the stack. Now, this is a step that you would be continuously doing, or iteratively you would be performing this till you reach the end of your postfix expression. Okay. So at the end of the postfix expression, you would have in stack the final result. Okay. So you just need to pop and print it on screen wherein you get the result. So this is how a postfix expression is evaluated. Okay. So this goes with the result. The result of your expression. I have listed the expression as well as the result to you. Okay. Now, this is not something that you really need to learn, but just understand that in stack application, we saw that the main things really we need to learn is reversing a line of string, and then conversion from infix to postfix expression, as well as evaluation of a postfix expression, which we just saw right now. Okay. I hope you understood it, Pushpendra. Okay. So apart from this, you have two more applications for stack. One for the recursion and the other for backtracking. Actually, you needn't learn this, but just understand there are applications like this also in stack. Okay. Now recursion. Okay. Recursion is a technique. Okay. Now what does the technique says? It solves a large computational problem. So this is a technique. Okay, so both of you are pulling the leg of each other. I don't understand. What are you both trying to do? Okay, so recursion is a technique for solving so recursion is a technique for solving a large computational problem. Okay, so you have a very big problem. So in this case, to solve such a big problem, you use the technique of recursion. Now, what exactly is the technique? It is repeatedly applying the same procedure. So you have a procedure, and this procedure is being repetitively done to reduce it, because your problem was very big or large. So this would be reduced to successively smaller problems. Okay. So this is the technique of recursion. Now if you ask me where you apply the technique recursion, I would say in functions. You remember we learning functions, right? So inside the function, we use the concept of recursion. So whenever you are using the technique inside a function, that particular function is called as recursive function. Is the idea clear? A function is said to be recursive function if it calls itself. Now let us see an example. See D, E, F, A, you have the function bracket followed by the colon symbol, right? Now what does this statement indicate? This is the function header. So you are actually trying to define a function here. Is it okay? You're trying to define a function here. And what is the name of the function? The name of the function is A. Okay. Do you have any values being passed to the function? No, it is a very plain function. So what happens is, when you try to call the same function inside A, what happens? You call it as the concept of recursion, and the function A is called as recursive function because it is calling itself inside the body. Okay. So what you need to keep in mind is whenever you are writing a recursive function, there will be a part which would be recursively called. That means repetitively called. But you cannot just keep on calling it because you would end up in an infinite loop, right? So there has to be a termination condition. So a condition which would tell you when to stop this repetitive call. So this is what we call it as the limit. Now what happens when you're trying to call a function more than once? So each time the control gets transferred from one point to another. Now you have to come back to this point also, right? To the starting point. So what you need to do is whenever you are jumping to a new point in the memory, or say the control getting transferred to another segment in your program, the status of your previous segment has to be stored somewhere. Okay. So when you're jumping from 1 to 2 and from 2 to 3, that means definitely after the work being completed at 3, you need to move to 2. After completion of the work in 2, you need to move to 1, right? So you definitely need to go back to the point where you have been called. So if you have to go back like this, your previous status has to be stored somewhere, and for this purpose we use the concept of stack. Okay. And why stack? Meaning because the LIFO technique. Okay. So in executing a program with a recursive function, the computer creates a function stack. Why a function stack? Because the item node contains the return addresses. Okay. Now in the function stack, it is a stack of frames where each frame corresponds to a function invocation. Now what is a function invocation? You are calling a function, right? Function invocation is nothing but a function call. So inside the stack you would have different frames and each frame corresponds to a function call. So this would tell you where to transfer your control and where to come back after executing the function. Is the idea clear? So the computer works on executing the function at the stack stop. Okay. So as I told you, you have imagined that you have three functions and this is how the control would be transferred. And if you want to get back after the work being done in 3, you need to get back to 2 and not 1, right? So immediately what would be on top of the stack? Definitely just the previous element that was inserted. So similarly, this is how the control gets transferred. Okay. So when the function at the stack stop returns, the computer removes that function's frame. Is the idea clear? So what would happen? The computer removes the function frame once you see that. See, I had a function called to 3. Now after 3 getting executed from the stack, I know that my return address is at 2. Now do you have to have this function call again in your stack? No. You pop and remove this off. Okay. This is what is being said in the third bullet. Is the idea clear? So how stack is used in the recursion, and it is the idea of LIFO technique of the stack that it is used in the concept of recursion. Okay. So the last technique or the application is backtracking. Okay, tracking means you are tracing the route, right? Backtracking means it is not in the forward direction but in the backward direction. Okay, so in the process of backtracking also you use the concept of stack. Is the idea clear? For backtracking also you use the concept of stack. Now let us understand what backtracking is. It is a general algorithm for finding all the solutions to a problem that incrementally build candidates to the solution. So every time the candidates will never be your final solution. It is just a path you have chosen to check whether you will reach the solution. Is the idea clear? Every time the candidate is never the solution, but you're just taking it to see whether you reach this particular solution. As soon as it determines that a candidate cannot possibly be the solution, what you have to do, you just leave it there and then backtrack. Okay. Now imagine that you are trying to find a route to your destination. So you start from the source and then you end up at a junction where you have the deviation, I mean the road getting cut into two directions. Now you need to make a choice whether you need to choose the path on your left or the path on your right. Now you're taking an assumption and following the path on your left and you find that this is a dead end. You're never going to reach the destination. Now what do you have to do? You need to come back to the way where you took the deviation, then choose the other path. Only then you're going to reach the destination, right? So how did you come back? You could backtrack the positions only because you had the exact route to you, right? So this is the process of backtracking. Now you know the game Sudoku, right? When you're trying to fill in numbers inside the cells. Okay, in Sudoku, what happens? You try to enter numbers into the cells, right? So when you're trying to enter, what happens? At some point of time, it will be like a deadlock. That means you cannot further add any numbers. In this case, what you would do, you would erase the previously entered numbers and then start off again, right? So this is a process of backtracking wherein you use backtracking to come back to a previous position and then start finding the solution again. Okay. So whatever solutions that you find on your pathway are called to be candidates. And these candidates need not be your final solution. So this is what backtracking says. Okay. So please have an understanding about recursion as well as backtracking. And in both the cases, you use the data structure stack. Now, how the stack usage and backtracking? See, as you're moving through a route, you need to give the landmark of each of the route. You need to push it into the stack. Only then, when you're coming back through the same route, you can pop and see whether you're going in the correct route. Is the idea clear? And hence backtracking. अच्छा तो आप लोग टाइम पास के लिए आए हो So with this we have come to an end of today's session. So what we have learned in today's class is we were learning the applications of the data structure stack. In the last class we covered two of the applications wherein we learned reversing a line of string as well as we saw how to convert an infix expression to a postfix expression. And then today we saw the other three applications, which is evaluating a postfix expression, the process of recursion wherein you are using stack, as well as backtracking where you used again the concept of stack. Now apart from all these things, we also learned the advantages of postfix expression over the infix expression. Okay, why we need to go for postfix expression when compared to infix? What was the actual reason? Now, infix expression is something that is very easy when we, I mean, from the human's point of view, because we are more used to infix expressions, right? But we are not that fluent with the postfix or prefix expressions. But when you're writing an infix expression, um, you need to be very careful about the precedence. That means the order of evaluation, the priority given to the operators as well as the associativity, right? There has to be parentheses or brackets inserted to show the evaluation order. But this was all very tough, right? In the case of infix expression. But when it came to postfix or prefix, what we saw was there was no parenthesis or brackets in both the notations. Okay. Now the notation itself would tell you which is the order of evaluation also. Okay. So this was very easy when it took the case of the computer to understand. So I hope you have all followed what we have learned today. Yes, Riyansh and Pushpendra, you actually triggered the class. Okay, so thank you. And with this note, I am bidding good night to all my dear students, hoping to meet you all on the next class. Okay, so we'll not be having a session tomorrow, but we'll be having one day after tomorrow at the same time in YouTube. So before bidding good night, let me remind you of my referral code SLYT, which would help you in getting a 10% discount on the fee of an academy subscription. Also, so if you are wishing to take a subscription, do not hesitate and please use the code referral code so that you get a 10% discount. And with this note, good night to all my students. Thank you all for joining and hoping to meet you all in the next class. Okay, so as I told you, we'll not be having a session tomorrow. Instead, we'll be having a session day after tomorrow. Okay, so bye.